For this problem, we need to write out the partial fraction decomposition. When we look at our expression, we see that we have a repeated linear factor in the denominator. That means that our partial fraction decomposition will take on this form. We'll get a divided by x plus 3, our linear factor, plus b divided by x plus 3 quantity squared. We take on that form. We want to clear the fractions. We're going to multiply both sides of this equation by x plus 3 quantity squared. If we do that, we end up with the identity 3x plus 7 equals a times x plus 3 plus b. We want to clean this right-hand side up just a little bit. 3x plus 7, we're going to get ax, and we're going to have 3a plus b, and we're going to group that together because that's going to be a constant. So here we have an x term and a constant term, and we also have an x term and a constant term on the other side. This is an identity, so what we're going to do is equate the coefficients from both sides. So we'll have 3 is equal to a, because 3 is the coefficient on x here, and it's the coefficient on x on this side. The constant on the left is 7, and our constant on the right is 3a plus b. So this gives us a system of equations in two variables, but we can see in the first equation a is equal to 3, so that already tells us what a needs to be. We can substitute that into our second equation to find out b. So we'll have 7 is equal to 3 times 3 plus b. 7 is equal to 9 plus b. Subtract 9 from both sides, and we'll see that b is equal to negative 2. Since we know what a and b are, we can do our partial fraction decomposition. And we'll say that 3x plus 7 divided by x plus 3 quantity squared is equal to 3 divided by x plus 3 plus negative 2 divided by x plus 3 quantity squared. We could bring the negative down if we want and say that's 3 over x plus 3 minus 2 over x plus 3 quantity squared.